document camera. Hi, everyone. And what I wanted to do was work some commonly misunderstood homework problems, particularly from the isotopic abundance homework. So I'm about to work number 7 because it was a commonly requested one. So number 7 told us that neon 20 has a 90.24% abundance in nature. So we're dealing with neon. Let me zoom in. There we go. So we're dealing with neon, and they tell us that neon 20 has a percent abundance of 90.24%. So I'm going to set up a chart kind of. So here's the isotope I'm dealing with. Here's its percent abundance. I'm going to shorthand abundance because it's a lot to write. I'm also going to convert that percent abundance to a decimal. And I also need the mass number. Right, I need the mass number for that isotope. And if you recall, right, the mass number is just that number that's in front of the name, right, in our isotope notation. So we've got neon and we've got that 20, so our mass number has to be 20. And we're going to include our units of AMU. So they tell us the percent abundance is 90.24%, right? If we do a little quick math, we're going to send our decimal to the left like Beyonce. And we're going to have a decimal of 90.24%. Oh, excuse me, not percent. 90.24. All right, it's going to be our decimal. And it tells us that we have 2 other isotopes of neon. They're neon 21 and neon 22. And we don't know the percent abundance of either one of these isotopes. So we can't convert it to a decimal yet, but we do know the mass number. So let's just focus on the things we know for right now. And the mass number for neon 21 would be 21 AMU. And same thing for neon 22, right? We're going to be dealing with 22 AMU. All right, this is the part where people got confused, right? About the things that you don't know. All right, there's one more bit of information that you do know, technically, is a known piece of information, and that is the average atomic mass of neon. So the average atomic mass of neon, we're going to take to our periodic table, and I don't have mine super handy. Here it is. There we go. We're going to take to our periodic table, and if we check out neon, it's a noble gas. We'll talk about what a noble gas is later in the class. If you're familiar with it, that's fantastic. If you're not, that's okay. But neon is going to be on the far right-hand side of our periodic table. You take a look at the average atomic mass that's listed, you'll see that it is 20.180 AMU. So we do know the average atomic mass, and that gives us a little bit more information to be able to solve for the percent abundance of these 2 unknown isotopes, right? So what we'll need to do is, remember in algebra, right, when you don't know something, what do we call it, right? We call it a variable, and we can call it any variable we want. Me, I just prefer to use X. So I'm going to set one of these isotopes decimals, right, because we're dealing with the decimals. So I'm going to set one of these to be X. I'm going to choose neon 21, just kind of arbitrarily. It doesn't really matter. So I'm going to call this decimal X because I'm solving for it. And I also don't know neon 22. It's not going to be the same percent abundance and therefore decimal as neon 21, but I can name it something different. If you recall, right, all of these percent abundances have to add up to 100, right? So if I take 100, and I subtract off the percent abundance that I already know for neon 20, right? So I'm going to subtract off 90.24. If I do a little bit of quick math there, I'm checking my paper so that I don't have to pull out the calculator again. Here we go. So it's 9.76%, right? So that 100% minus the 90.24%. So we know that the percent abundances of neon 21 and 22, when we add them together, have to add up to this 9.76%. Okay, and we're going to set this one to be X, right, neon 21, and we know that together they have to equal 9.76%, or if we converted that to a decimal, 0.0976, right? So the percent abundances as a decimal of neon 21 and 22 have to add up to this number. If I set one of them to be X, then the other one should be 0.0976 minus x. All right. This problem's going to work a lot like number 4 did. I think that was the one with boron, and they gave you 2, or silicon, excuse me. So number 4 and number 6, actually, the one with silicon where they gave you 2 isotopes and you don't know the percent abundances, right? You said one is x and the other one is 1 minus x. Same thing with number 6 with boron. So you said one is x, the other one as 1 minus x. In this case, you already know one of the isotopes, so you subtract off the part that you know. Now you're left with the part that you don't know. So you know that one of them has to be x and the other one has to be what we don't know yet minus x, right? Now we have enough information to set up our problem. So we know that our average atomic mass, all of those contributions, those weighted contributions together should equal our average atomic mass of 20.180 atomic mass units. All right, and here's where I'm going to set up all of the weighted contributions, right? So I know that neon 21, neon 20, so 20 AMU. And we're going to multiply that by its decimal, so 0.9024. Then I'm going to do the next one, so neon 21, so 21 AMU times its decimal. We don't know yet, we're calling it x. We'll solve for it in a second. And last one is 22 AMU. This is the last isotope. And we're going to multiply that by its decimal. Once again, we don't quite know it, but we have something we can place in its, put in its place until we can figure it out. So that's our 0.0976 minus x. So at this point, we're just dealing with algebra, right? So we're going to do a little bit of arithmetic. We'll multiply together our 20 AMU and its percent abundance as a decimal. If you do, you'll end up with 18.084, and I believe that's actually the number that you get in the calculator. So this isn't rounded, right? I'm not rounding anything yet. All right, and we've got 21x plus 22. Cool, I've got erasable pens. So if I make a mistake, it's okay. All right, and for our 22 here, you can see that we're dealing with these parentheses here. Remember, if you got a number outside of your parentheses and some numbers inside, we're going to do some distribution. So we'll distribute our 22 to this decimal as well as to the negative x. If we do, I'll go ahead and do the distribution in this step. And if you do, you'll end up with 2.1472. And so that's our 22 times the 0.0976. And negative x times 22 gives us negative 22x. You can see here that now we're going to go ahead and combine our like terms. So I'm going to go ahead and circle those. We've got our 21x and our negative 22x. We can combine those. So those are like terms. And we also have, looking for a different color, use a few orange. We also have our 18.084 AMU. And it looks like I dropped my units. Yeah, I've been dropping my units. Don't drop your units, guys. It's a bad habit to develop. All right, and I can also combine these together. All right, so these are the same kind of terms. So we'll combine those together. And when we do, we'll still have our 20.180 AMU on this side. On the other side, we will have 20.1952 AMU. And we're going to combine our x's, so we'll end up with negative x. At this point, right, we just got 2 steps left. We're going to subtract on both sides. When we do that, we are left with negative 0.0152 on one side, and on the other side, we're left with our negative x. At this point, we're going to divide both sides by -1. The way that I like to do that is I'll just change both of these negative signs into positives, right? Because it's still a true statement. So I'll see that my x, this decimal here, up at the top. So let's bring this back up. So our x, which is the decimal we were using as a placeholder for the decimal representing the percent abundance for neon 21, we can see that we end up with 0.0152, which if you converted that to a percent, you would end up with 1.52%. At this point, now we know that the decimal, right, that's equivalent to the percentage for neon 22, right, we can use this information to go ahead and just solve for this decimal and then that percent abundance, right? We have this 0.0976 minus, now we know that this is 0.0152. So we'll do that 0.976 minus 0.0152. And if you do that, you should end up with 0.0824, I believe. Yes, 824. This is an 8. My 8s are not that great. And if you do a little decimal movement, right, moving this decimal back 2 places to the right so that we can get our percentage back, you'll see that we have a percent abundance for neon 22 as 8.24. Right, so these two would make up your answers for number, this is number 7. All right, so I'm going to leave this on the screen for just a moment